What's up? I'm Vin, and today I want to go through this 2022 New York State test for grade 7, and I'll leave a link to a copy of this test in the description below. Now let's get started. So this is the reference sheet that we're going to get for the test, and we also get to use a scientific calculator for both sessions. Question 1, based on a weather report, the probability that it will rain tomorrow is 0.13, and we want to know which word describes the likelihood that it will rain tomorrow. So 0.13, just know this means 13 hundredths, and that's 13 out of 100. And if I want to write this as a percent, that's 13%. So now let's look at the answer choices here. If there's a 13% chance of rain, certain would be 100%. Okay, so if we said on the weather report that 100% it's going to rain tomorrow, that means it's definitely raining tomorrow, but this is not 100%. So A is out. Impossible would be if there is a 0% chance of rain. Okay, that means there is no way it is going to rain, but a 13% chance it could happen. All right, so now we're down to likely, unlikely. Likely is almost 100%, okay, close to 100%. And unlikely would be almost 0% or close to 0%. So when I look at 13%, I think about where does this number belong? Is this number almost 0 or is it almost 100? And once again, you could also think close to. So this is not close to 100. Okay, this is close to 0. All right, just think if this were a test grade. All right, is this test grade closer to 0 or 100? Like, are you probably going to get a reward for this grade, or your parents going to be upset at you if you get this grade? They're more likely to be upset if you bring home a 13%. I mean, I hope you never do, but yeah. So this is almost 0, unlikely. Okay, if there's a 13% chance of rain, it is unlikely that it will rain. So choice D is our answer. Question 2, two stores each advertise a discount on the same type of watch, and at both stores, the original price of the watch was $35. And now we have store A discounts the price of the watch by 20%. Okay, so that is a 20% discount, and then store B discounts the watch by 15%. And we want to know how much less is the discounted price of the watch at store A than the discounted price of the watch at store B. So for this one here, we're going to be taking 20% off of $35. So if I do 35 and I multiply by 20% is 20 out of 100. So I could just multiply by 20 out of 100 like this. And that's going to tell us how much the discount is at store A. So we have this, and there's a $7 discount. So what we could do is we could take 35 and subtract 7, and this is going to tell us the price of the watch after the discount. Now, one thing I like to note here is I think of percent on and percent off. If they are taking 20% off, that means 80% is still on, because 80 plus 20 would make 100%, which would be the entire price of the watch. So watch what happens if I do this. If I do 35 times 80%, that's going to give us the exact price of the watch after the discount. Notice that we get 28. One thing to also be mindful of is that 80 out of 100 is the same thing as multiplying by 0.80 or even just 0.8. Okay, this also gives us 28. And now store B is discounting the price of the watch by 15%. So here, if we take 15% off, that means that 85% is still on. Okay, so we could do the price of the watch is 35 and we're leaving 85% of the price of the watch on, and that gives us this amount here. Now, we could also just take the price of the watch, 35, and subtract 15% of 35. So I could take 35 and multiply by 15% or 0.15, and that's going to give us the same value here of $29.75. But now the actual question is, how much less is the discounted price of the watch at store A than the discounted price of the watch at store B? So now I would just take those two numbers here and subtract. So 29.75, and I'm going to subtract 28, and this will tell us the difference in the prices of the watch after the discount. So the difference in the prices of the watch is $1.75. Now, one thing here, this is a test where you do get to use a scientific calculator, but let me show some of this math by hand. I'll just do one of them. Let's say I want to do 35 times 0.85 by hand. So for something like this, if I want to do 35 times, and we're doing 0.85 here like this, what I would do on the side is do 35 times 85. And then I'll worry about the decimal places at the end. So I'm going to do 5 times 5 is 25, and I carry the 2. 5 times 3 is 15, plus 2 is 17. And then we put a placeholder. We have 8 times 5 is 40, so I have a 0, and I carry the 4. And then we have 8 times 3 is 24, plus 4 is 28. And now when I add these numbers up, I'm going to get 5, 7, 1 plus 8 is 9, and then I get a 2 here. And notice this would be if I did a 2-digit number times a 2-digit number in this form. But here we have this decimal place here. So notice here we have 2 decimal places that we ignore. So I'm going to write 2975, and I have to pay those decimal places back. I'm going to go 1, 2 like this, and that's why this would work out to 29.75. Okay, so this is just one way to get the 29.75 if we want to do this by hand. Another little trick here too, if we're taking 20% off, 20% is 20 out of 100, and this fraction will reduce to 1/5 if I divide the top and bottom by 20. So what I could also do here, if I want to do some of this math in my head or show more of the work on the side, is I could take the $35 and divide by 5, and that tells us that 20% of 35 is 7. And then if we do 35 minus 7, see how this also gives us the value that showed up in the calculator. We get the $28, which is the price of the watch after the discount at store A. Okay, so we can do some of this math by hand, but just know if you do get to use a scientific calculator, it is worth you typing in just to make sure that if you are going to do the work by hand, that you are getting things correct. Question 4, we have a spinner has 5 equal size sections colored blue, red, orange, yellow, and green, and the arrow on the spinner was spun 50 times during an experiment. And then we have the results are shown in the table below. And we have next, based on the results, what is the experimental probability that on any one spin, the arrow will land on the red section? So for this question here, we look over to the red, and the arrow landed on red 15 times. So we're going to say 15 over, and then we have to account for the total number of spins, which they told us is equal to 50. If we wanted to find it the long way, we could just take all of these numbers in the table and just add them up. But if we do all of this addition here, we should get 50. So now we scan the answer choices, and it looks like they reduced this fraction. So we're going to divide the top and bottom by 5. And this would simplify here to 15 divided by 5 is 3, over 50 divided by 5 is 10. So we're going to get choice D. Now, one thing I want to point out here is it's very tempting to say that the probability is 1/5. However, this would be the theoretical probability. Okay, so the theoretical probability is if we just take any spinner that's designed fairly and there's 5 equal size sections that are colored these colors, then there should be a 1 in 5 chance, since there were 5 different colors, of landing on red. Okay, but in this case here, if we were to spin it, let's say 500 times, this number, if it was a fair spinner, would start to get closer and closer to 1/5. Okay, so 1/5 is equal to, if we write it as a decimal, 0.20, and this one here is equal to 0.30. So these numbers are fairly close together, so it's not so bizarre to get numbers like this, but once again, the experimental probability is based on the results of the experiment. Okay, so that's why we're going with 3/10. Choice D is our answer. Question 5, which expression is equivalent to what we have here? So for this question, we're going to use the distributive property. So we're going to do -3 times 2x is -6x, because we have a negative times a positive is a negative. And now we're going to distribute the -3 to the -8, but we're doing a negative times a negative next, which is going to result in a positive. And then I just do 3 times 8 is 24. And then we have that plus 4x at the end. So here we combine like terms. And when we're combining like terms like this, I just add the integers in front of the x's. So I'm going to do -6 plus 4 in my head. And -6 plus 4 is equal to -2. So we're going to have -2x, and then we're going to have plus 24. Okay, and this is going to match up with choice B. Question 9, the data set shown below represents the distribution of daily high temperatures in a city for 8 days. And we want to know what is the median daily high temperature in degrees Fahrenheit in the city. So for questions like this, we have to organize the data from least to greatest. So the smallest number in this list is 66. And then I just make a mark underneath the number so I know which numbers I already wrote down. And now next, the next smallest number would be 70. And then notice here that 72 shows up twice, so I have to write it twice down here. And then next we have 73. And then 75 will be the next biggest number in the list. And then for the last two numbers here, we're going to have 79 and 81. Okay, so here is the list in order from least to greatest. So now what I like to do when I'm looking for the median is I just cross off the ends. Okay, so I cross one off the beginning, one off the end. I cross one here, And then notice what happens is we have two numbers left in the middle. So when this situation pops up, what you have to do is you have to take the average of the two numbers. Okay, so I'm going to do 72 plus 73 and divide by 2. Now, sometimes you could just look at this and just think about this carefully and say, all right, 72 to 73, if you just have strong number sense and know that 72.5 is in the middle, then that's going to be your median value in this case, okay? But otherwise, you could use the calculator and do 72 plus 73 divided by 2. And that's going to tell you the middle number, which matches up with choice B. Question 10, the menu at an ice cream store is shown below, and we want to know how many different choices of one size, one flavor, and one topping can be made from the menu. So here we're going to use the multiplication principle. We're going to take the number of sizes of ice cream. So there's 3 sizes of ice cream, and we're going to multiply by there are 3 flavors, and then we multiply that by the number of toppings, which is 3. So if we just do 3 times 3 times 3, we're going to get 27, and this matches choice D. Now, if you're confused as to why we multiply here, I like to use the tree diagram to bring this question to life. So we start here, and we have 3 options for the size of ice cream. We have small, medium, large, and then we have 3 options for each flavor. So I'm just going to draw these branches kind of long, just so I have space here. So I have 1, 2, 3 coming out of each of these, and these represent the flavors. Okay, so we have 3 flavors popping out as well, like this. So this is what we have so far. Okay, so here's our tree diagram, and the flavors, remember, are vanilla, chocolate, strawberry. Okay, so vanilla, chocolate, strawberry. And we just write this like this, and now we'll just make a little bit of space here. So then the toppings, there are 3 options. Okay, there's dip, sprinkles, crunch coat. Okay, so 1, 2, 3 popping out of all of these. But if I want to, I can count the number of branches at the very, very end. Okay, so at the end of one of these branches represents a complete option that includes one size, one flavor, and one topping. Or we could just, once again, we just count straight down the line like this, and we're going to have, 1, 2, 3. And if we just count all the way down, there's going to be 27 total like this. But you could see 3 times 3 times 3 coming to life. There's 3 options first, and then there's 3 options for the second choice for the flavor, and then 3 options for the topping. And it's going to create 27 branches at the end. Choice D is our answer. Question 11, the cost for 10 ounces of organic blueberries is $2.70. And we want to know which equation can be used to determine X, the cost in dollars for 30 ounces of organic blueberries. So for this question here, let's just set up the proportion $2.70 for 10 ounces. Okay, and we're going to set this equal to the mystery value X. Okay, so it's going to cost X dollars for 30 ounces. Okay, so now if you look at the answer choices, none of them have units written there. And the $2.70, notice the trailing 0 is chopped out. So I'm just going to write 2.7 over 10 equals X over 30. Okay, and now we just scan the answer choices here. And let's see, we have 2.7 over 30. We have 2.7 over 10 equals. So this one here, you see it's swapped. So this one is no good. And I don't see our answer right away. Okay, notice I have 2.7 over 10 equals X over 30. But one thing you're allowed to do with fractions, and I'll show you over here. If I have something like 1/2 is equal to 4/8. Okay, this is a true statement. If I reduce 4/8, I get 1/2. But one thing I'm allowed to do, and this only works when you have one fraction equals another fraction, is you are allowed to flip both sides like this. Okay, so I could say that 2 divided by 1 equals 8 divided by 4. Okay, this is just as true as the previous equation. So what I'm going to do here is I'm going to flip this and say 10 over 2.7 is equal to 30 over X. And now let's look. 10 over 2.7 equals 30 over X. You're going to see this matches up with choice C. Question 19, which expression has the same value as the expression shown below? And we have -3/8 minus 7/8. Now, just looking here, I could see choice A is no good because when we subtract numbers like this, I just think of this as -3/8 and then plus -7/8. Okay, so A is no good. I think the confusion here is that if we were to multiply these two fractions, when I do a negative times a negative, this I could say is equal to the positive fraction times the other positive fraction. Okay, so that's the confusion here for choice A. Choice A is no good. Now, this one, choice B, we cannot just change the sign of the second number here. So choice B is out. But notice the two remaining answer choices, the first fraction, the sign was changed from negative to positive. So that's how this one here is no good. And then we look at choice D, we're starting with negative 3/8. And then instead of saying minus 7/8, you're allowed to say plus negative 7/8. Okay, so something like, let's say I have 8 minus 1. I could say that this is equal to 8 plus negative 1. All right, so subtracting a positive number is the same thing as adding the negative number. Okay, so that's just something that we're able to do when we're doing this type of arithmetic with integers, and in this case, rational numbers. So choice D is going to be our answer. Now, one thing you could do with your scientific calculator is you could do negative 3/8 and then subtract 7/8. Okay, and then just remember this decimal here. And then by the time you get down to the last answer choice, you do negative 3/8 and then plus, and then on the inside of the parentheses, I put negative 7/8. And notice that this gives us the exact same decimal value here. So choice D is definitely correct. Question 20, a chef made 150 cups of chili and sold 60% of it. And a serving size of the chili is 1 2/3 cups. And we want to know how many servings of the chili were sold. So for this question here, it helps to be able to turn 60% into either a fraction or a decimal. So 60% as a decimal is 60 out of 100, or 0.60. I could also say this. I could say 60 out of 100 and then divide the top and bottom by 20. And this fraction reduces to 3/5. Okay, so either one of these we could use here. But let's say I want to do this by hand first without the calculator. I'm going to do 150 and multiply by 3/5. And that's going to take 60% of 150. And now here, I'm just thinking 15 divided by 5 is 3. So if I do 150 divided by 5 first, I'm just going to write a 3 with a 0. And this product will work out to 90 now after I do 30 times 3. So this tells us that the chef sold 90 cups of chili. Okay, so 90 cups, this is how many cups were sold. And now here we have to use this idea that one serving size is 1 2/3 cups. So here, what we're looking for is how many servings of the chili were sold. If you just know to do 90 divided by 1 2/3, then excellent. Then just go ahead and from this step here, just divide. If that doesn't make sense, what we could do is we could set up a proportion. We could say that 1 2/3 cups is equal to 1 serving size. Okay, so we could just say this. Okay, so 1 serving size is equal to 1 2/3 cups. So then we could say, all right, well then whatever amount of serving, however many servings of chili were sold, we're just going to call that X. Okay, so X serving sizes, or we'll just say X serving size. So let's just think about this very carefully. So they're telling us, once again, 1 2/3 cups per serving size. So if we set up the proportion here and we put cups in the numerator and serving size in the denominator, we could just put X in place of the serving size here for the 90 cups of chili. And now when we cross multiply, you see we're going to have 1 2/3. Okay, so this value here times X equals 90 times 1. And now to solve for X, we're just going to divide both sides by 1 2/3. Okay, so I'm just going to move this down over here. All right, I'll move all this stuff over. So we have this. And once again, if the goal here is to solve for X, we would just divide both sides by 1 2/3. Okay, so that's the algebra behind what we need to do here to solve for X. All right, but once again, if you just understand from this step, once you get 90, that you need to divide 90 by 1 2/3, then don't do all this, okay? But the concept behind the scenes is proportions, okay? That we could set up a proportion here to solve for how many servings of chili were sold. So now from here, if we want to do this by hand, I would convert 1 2/3 into an improper fraction. So I would do 3 times 1 is 3, plus, and then we have that extra 2 over 3 like this. And then this works out to 5/3. Okay, so we have the improper fraction we could write as 5/3. So if I do 90 divided by 5/3, I'm going to use keep change flip. I'm going to keep the first term here. So I'm keeping 90. I change the operation to multiplication, and then I flip the fraction after the division sign here. So I'm going to flip this to 3/5. And now if we do the division here, 90 divided by 5, we just work this one out, that's going to be 18. Okay, so 90 divided by 5 is 18. And if we do 18 times 3, that's going to give us 54. Okay, so we would get 54, choice B. But from this step, if you just want to do 90 divided by 1 2/3 in the calculator, you could just do 90 divided by, and then I'm going to put parentheses here. I'm going to do 1 plus 2/3. Okay, 1 and 2/3, just know, is equal to 1 plus 2/3. It's just we don't write it out like this because it looks a little sloppier with the addition sign. We just squeeze those two together. But 1 and 2/3 means 1 plus 2/3. And if we do this division here, see that we also get 54. So choice B is definitely correct. Question 21, at sunset, a thermometer had a reading of 4 degrees Fahrenheit. During the night, the temperature decreased 15 degrees Fahrenheit. And then after the decrease, we want to know what is the total number of degrees that the temperature must change for the thermometer to read 0 degrees Fahrenheit. So for this one, if we're starting with a reading of 4 degrees Fahrenheit, and I'll leave the units out for now, and we decrease by 15, we're doing minus 15. Now, the math that I do in my head is when I want to do 4 minus 15, I just think 15 minus 4 is equal to 11. So if I reverse these, 4 minus 15 would be equal to negative 11. Okay, so this is just a nice trick when you're subtracting an integer that is greater than the integer in the front. Okay, so I just think of the easier way of doing this and then throw a negative in front. So let's think about this carefully. If the temperature right now during the night is negative 11 degrees Fahrenheit, what is the total number of degrees that the temperature must change for the thermometer to read 0 degrees Fahrenheit? Well, to get from here to 0, just think about this on the number line, and I can even make this vertical so that it looks like a thermometer. If we're right now at negative 11 and our goal is to get back to 0, we would have to go up 11, okay? I would have to go plus 11 here to get back to 0. So choice B is our answer. Question 25, a gardener uses a total of 61.5 gallons of gasoline in 1 month. Of the total amount of gasoline, 3/5 was used in his lawnmowers, and we want to know how many gallons of gasoline did the gardener use in his lawnmowers in 1 month. So for this question here, we take the total, okay, so there are 61.5 gallons of gasoline, and we multiply by 3/5 because they're telling us in the next line here that the gardener uses 3/5 of the gasoline in his lawnmowers. Okay, so that's why we're going to multiply by 3/5 here. So we could just do 61.5, and we're going to multiply that by 3/5. So I could just do parentheses 3 over 5. Remember, in math, parentheses means multiply, and this gives us this value here. So our answer here is choice D. Now, if we want to do this by hand, we could take something like 61.5 and divide it by 5 and do the long division. So I would do 5 goes into 6 one time, and we have 1 times 5 is 5, and we subtract, and we get 1, and then we bring down the 1 here. 5 goes into 11 twice, and then we have 2 times 5 is 10, and we have a remainder of 1. Okay, let's just make this a little bit neater. So we have a remainder of 1, but notice the decimal is here, so I'm going to put the decimal up here like this, and now I bring down the 5, and 5 goes into 15 3 times, and it goes in evenly. 3 times 5 is 15, and when we subtract, 15 minus 15 is 0. Okay, so I divide by 5 first, and I get 12.3. But then if I do 12.3 times 3 on the side, I have 3 times 3 is 9, 3 times 2 is 6, and then 3 times 1 is 3. And I ignored 1 decimal place. I did 123 times 3. So I just have to pay 1 decimal place back and move this decimal to the left, and I get 36.9. Okay, so we can do this by hand. But once again, if you get a scientific calculator, you could just type this expression in and you'll get choice D. Question 26, a machine in a factory makes 2 1/4 pounds of nails in 1.5 hours. And we want to know at what rate in pounds per hour does the machine make nails. So the units here are pounds per hour. So notice they told us that the machine makes 2 1/4 pounds, and I'll write lbs, per 1.5 hours. So when I set up my ratio here, I'm very careful and making sure that I'm setting up pounds per hour. I'm putting the pounds up top and the hours on bottom. But now what we're looking for here is, in a sense, we're looking for the unit rate. They don't say what is the unit rate, but if they're saying in pounds per hour, they want us to divide these two numbers. So we're going to do 2 1/4 divided by 1 1/2. Now for this one here, if I want to do this by hand, I'm going to first turn these numbers into improper fractions. So I'm doing 2 times 4 is 8, and then 8 plus 1 is 9. So I have 9 over 4. I'm keeping that denominator the same. Pounds per, and then for hours, I'm doing 2 times 1 is 2, plus 1 is 3, and the denominator 2 is going to stay. So now I could use keep, change, flip. I'm going to keep the fraction on top. I'm going to change the operation to multiplication, so that gets rid of this fraction bar. And then I flip the fraction on bottom like this. Okay, my units are pounds per hour. All right, and I'll make this singular so that it matches the question, pounds per hour. And now here, I could just cross cancel. 9 divided by 3 is 3. And then 2 over 4 reduces to 1/2. Okay, so this is going to reduce to 1/2. And now if I just multiply that stuff out, 3 times 1 is 3 over 2 times, and I could just say here, this is an invisible 1. 9 divided by 3 is 3, but there's just, think of this now as a leftover 1. So I just have 2 times 1 is 2, and the units are pounds per hour. Okay, I'll just make that a little bit neater. So we have pounds per hour, and now we just scan the answer choices, and we're like, oh no, our answer is not there. So what we have to do from here is turn this back into a mixed number. Okay, so now I could just do this on the side. If you just know that this is 1 1/2, then excellent. Okay, so 1 1/2 pounds per hour. Or I could just do 3 divided by 2. 2 goes into 3 once. 1 times 2 is 2. And when I have my leftover 1, my remainder 1, I'm dividing by the original 2 here in the divisor spot. So 1 1/2 is going to match up with choice C. But if you just want to use your scientific calculator, do parentheses 2 plus 1/4. So I just do 2 plus 1 divided by 4. I close the parentheses, then I do divided by, I open a new parenthesis, and then 1 1/2, I'm going to write as 1 plus 1 divided by 2. Okay, and I press enter, and this gives us 1.5. And hopefully from this step here, you would see that choice C has to be the answer. 2/3 is less than 1, 3/4 is less than 1, and 1 1/2 is equal to 1.5. We could even check here if I did 1 plus 1 divided by 2, that's going to give us a matching decimal of 1.5. So choice C is definitely our answer. Question 28, the table below shows a proportional relationship between X and Y, and we want to know what is the constant of proportionality for the relationship between X and Y. Now for this question here, we need to know this formula Y equals KX, and K represents the constant of proportionality. And what this means, the concept behind this, is that if I take X and I multiply it by this value K, that's going to give me Y, and that's going to work no matter which X value I choose. Okay, so if I do 0.5 times K, I'm going to get 0.75. If I do 3 times K, that's going to give us 4.5 for Y. So I could pick any one of these pairs to help us solve for K. So let's say I pick the first pair. So I'm going to plug in Y is 0.75, and I'll leave that 0 off at the end just because that's not going to add any value. And this is equal to, we have K times X is 0.5. But this time I'm going to write a 0 at the end, just because when I do the division here, I'm dividing both sides by 0.50. The math that I'm doing in my head, I'm imagining that I'm doing 75 divided by 50. Okay, so I'm doing, once again, in my head, if I want to divide these decimals, I'm doing 75 divided by 50. And then this, I would just reduce, I would divide the top and bottom by 25. And that's going to give us, we would have 3 over 2. Okay, so 3 over 2, this would reduce to. And 3 over 2, I could say is our K value here. So K is equal to 3 over 2. And 3 divided by 2 simplifies to 1.5. Okay, so choice C would be our answer. Now, one thing, I could also use this pair of points. Let's say I had plugged these points into the equation to solve for K. That would give us, we would have 4.5 is our Y is equal to K times X is equal to 3. And if I divide both sides by 3, that would tell us that K is 4.5 over 3 is equal to 1.5. Okay, so we get the same K value, which we should because K is constant. If I had to write an actual equation here, I would plug in K equals 1.5. And now this equation here will give us any pair of points in the table, or if I need to build more values in the table here, I could just pick random X values, multiply them by 1.5 to get the corresponding Y value. Question 31, Mr. Jensen purchased an airline ticket on a website and the original price of the airline ticket was $473. He used a coupon code to receive a 20% discount and a sales tax of 12% was applied after the discount. And we want to know what was the total purchase price of the airline ticket after the discount, including sales tax. So for this question here, we're starting with the $473 and we're taking 20% off. Okay, so 20% of this price is coming off. All right, now one thing I want to point out here, taking 20% off is the same idea as keeping 80% on. And I like to do 80% on because this is faster. Okay, when you're taking a discount, looking at the percent of the price that's still on, this is faster. Okay, and then from here we have to apply, after this step here, we get some value, we're going to apply the tax of 12%. Okay, so 12% tax, we apply the tax, but one shortcut here would be to take the 12% and multiply by 1 plus 12%. Okay, so this is another shortcut that is faster. All right, so I'm just going to show how to do this a few different ways. But once again, what I'm writing underneath here is the faster way if you're looking for a quicker method for solving this question. So now let's do the math in the calculator. So we're starting with the price of $473 and we're taking 20% off. So I'm going to do minus 20% of 473. So 20% is 20 out of 100, or 20 over 100. And we're going to multiply that by the price of the airline ticket. Okay, so doing this takes 20% off. All right, now one thing I mentioned here is that it's faster to just calculate 80% of 473. So if I do 473 and I find 80% or multiply by 0.80, because 80% is 80 out of 100 and that's 80 hundredths. Notice that I get the same value here. So this is the price of the airline ticket after the discount, but we also have to apply the tax of 12%. So what we could do is we could take this price, 378.4, and then we could add 12% of this price here. So I'm going to do 12% is 12 out of 100. And we're going to multiply that by the price after the discount here. Okay, so this is what's happening. And this gives us 423. And if we round to the nearest cent, that's 81 cents. So I can see right away this is going to be choice C. But one thing I mentioned over here is I could take that price, 378.4, and I could multiply by 1 plus 12%. Okay, so if I just add the tax to 1 like this, and I multiply by 1 plus 12% is, I could just write out 1 plus 12% like this. I could do 1 plus 12 over 100, and that gives us the same exact value here. Okay, now one thing I do want to point out, they did say that the discount was applied first and the tax was applied after the discount, but the order actually doesn't matter. If I start out with the original price here of 473 and I apply the tax, I multiply by 1.12 and I get this value here, and then I take 20% off or I keep 80% on, multiplying by 80%, notice that once again I get choice C. So either way we could do this, we're going to wind up with choice C. So question 31, our solution is choice C. Question 32, we want to know the value of this expression here. So for a question like this, we could just type everything in the calculator. We could do 12.5 minus 31 over 2. And then next I have plus 1 1/4. So 1 1/4, I'm going to write it as 1 plus a fourth. If you know 1 1/4 is 1.25, you could also just add that number here. And now I press enter and I get negative 1.75, which doesn't match A or B. But looking at the remaining answer choices here, this is looking like choice D. If I do negative 7 over 4, see how that gives negative 1.75. And the way I knew that is if I did 16 over 4, I know that's equal to 4. So we would have here negative 4.25 if we divide. Okay, so if we work this out, notice that this is not matching the original expression here. So just using the calculator, we would get choice D. So our solution here is choice D. Now, this question, we can do everything in the calculator, but I will show how to do this math by hand, because if you just use the calculator, like, yes, you will get a higher score on the test, but you should make it a goal to learn the concept behind everything as well. So here I have 12.5, which I'll write as 12.5 over 1. And then I'm going to make a space here. I'm going to have minus 31 over 2. And then for this last part, I'm going to write 1 1/4 as an improper fraction. So I'm going to do 4 times 1 is 4, and then plus 1 is 5. So I have plus, and then we're going to have 5 up top, and the denominator I'm going to keep as a 4. So this is 1 1/4 as an improper fraction. And now my goal here is to make common denominators. So here I would multiply the top and bottom by 4. And my goal here is to have a common denominator of 4. So that's why I'm multiplying by 4 over 4. I'm looking at the original denominators of 1, 2, and 4. And I know that these numbers here, the least common multiple that they have in common is going to be 4. Okay, so if I just list out the values here for the times tables, notice that 4 is the first value that they all match at. So here I would have to multiply the second fraction by 2 over 2. And this third fraction, I could just leave it alone because it already has a denominator equal to 4. So now for this next part, I could use a calculator, but I'll just go ahead and practice some mental math. If I want to multiply 12.5 times 4, I'm going to do 12.5 times 2 and then times 2 again. So 12.5 times 2, if I multiply these first, that's going to give us 25, and then 25 times 2 is going to give us 50. Okay, so for this first part here, we're going to have 12.5 times 4 is 50 over 4, and then we have minus 31 times 2 is 62 over 2 times 2 is 4, and then we have plus 5 over 4. So now I can combine these into a single fraction here. Notice they all have the same denominator. So I could say now 50 minus 62 plus 5 all divided by 4. And now for this part, I'm doing 50 minus 62 is negative 12, and then I have negative 12 plus 5, and we're over 4. And now here, I'm just thinking 12 minus 5 is 7. So if I do negative 12 plus 5, that would give us negative 7 and then over 4. So choice D is definitely correct. Question 33, on a map, two cities are 2.8 inches apart, and the map has a scale of 1 inch to 25 miles. And we want to know how far apart in inches would the same two cities be on a map that has a scale of 1 inch to 40 miles. So for this question here, there's multiple stages we have to go through. But first, let's just consider that on this map, so we have our first map, the cities that we have here and here are 2.8 inches apart. And they gave us a scale for the first map. The first map, 1 inch on the map, corresponds to 25 miles. So we could use this ratio to set up the proportion 1 inch over 25 miles equals 2.8 inches over X miles. Okay, so this will tell us how far apart the cities are in real life. And notice I have inches over miles. So in my second ratio, I set up inches over miles. You want to make sure you don't mix these up, because then that's just going to throw the whole question off. So now I just multiply the numbers and the variable together. So I have 1 times X is equal to X. And then I have 25 times 2.8. So we just work out this product in a calculator, and this is going to work out to 70. Okay, so this tells us that the two cities are 70 miles apart. But now the actual question here is how far apart in inches are the two cities on this other map that has a different scale of 1 inch to 40 miles. So we set up another ratio, 1 inch over 40 miles, and we're going to set this equal to, we have X inches, or since we already used X, I'll go ahead and use Y. So I'll say Y inches over 70 miles. Okay, so now we cross multiply, and we're going to have 40 times Y is 40Y equals 1 times 70 is 70. And now to solve for Y, the number of inches, we're going to do divide by 40 on both sides. Okay, because we have 40 times Y equals 70. The opposite of multiplying is dividing, and that gets Y by itself. So Y equals, and this I could just do 0 over 0 canceling out. When you have numbers that have trailing zeros like this, you could just chop them like this. And now 7 divided by 4 is 1 with a remainder of 3. And we were originally dividing, well, after this cancels out, we have 7/4. So our new denominator is going to be 4. And 1 3/4 is equal to 1.75. Okay, and the units here were inches. So that tells us that the cities are 1.75 inches away from each other. So choice C is our answer. So now we move on to the session 2 questions. And for question 34, we have Caitlin wants to buy a $75 skateboard, and she has $25 saved so far. And she mows lawns to make extra money, and she will earn $20 for each lawn that she mows. And we want to know which inequality can be used to determine the number of lawns X she needs to mow to have enough money to buy the skateboard. So for a question like this, what you really want to pay attention to is the difference between this number 25 and this number 20. Now, what I mean by that is 25 is a fixed amount. Okay, she has $25 saved so far. So this amount here is just not changing. But what is changing is how much money she has based on how many lawns that she mows. And they tell us over here that she's going to earn $20 for each lawn that she mows. Okay, so this information here is all connected. Okay, it's $20 for each lawn that she mows. So we're starting off with $25, and then every time she mows a lawn, she's going to get $20. So we're going to say 20 times X, where X is the number of lawns. And you could just think about this. If we had a few numbers here to plug in, let's say she mows one lawn. Well, she would have 25 plus $20, which would be $45. If she mows two lawns, she has $25 already. If she mows, once again, two lawns, we're going to do 20 times 2. So she would make $20 twice, and that would give us 25 plus 40, which would give us 65. Okay, so that's why here we could just say 25 plus 20x, where x is the number of lawns that she needs to mow. But now let's think about this last part very carefully. She needs at least $75 to buy the skateboard, okay? So that means her money here, so this is her total money, has to be greater than or equal to $75. Because if you think about it, if Caitlin were to show up with less than $75, they wouldn't give her the skateboard. If she just mows, let's say, 2 lawns like this, she would have $65. That wouldn't be enough. They're not going to sell her the skateboard. So that's why if you think about this last part very carefully, her total money has to be greater than or equal to $75. Otherwise, she won't have enough money to actually buy the skateboard. So now we look through the answer key and we could see that this is going to match up. Let's just see here. This is going to match up with choice B. So we have 25 plus 20x is greater than or equal to 75. A is close. You could see the expression is correct, but we can't have less than $75. We would have to have greater than or equal to $75. Okay, this says less than or equal to, but once again, we would need greater than or equal to here because she can't have less than $75 or they will not sell her the skateboard. Question 35, we have a coach compared the heights of the players on 2 different teams and the data set is shown in the table below. And we have the question here, based on these data, which statement is true? And notice that all of the answer choices make mention of the mean, the median, and that's really the only data we're looking for between both of these teams. So let's say we want to find the median value. Well, for the median value, I would have to rewrite these numbers in order from least to greatest. So looking at this first list, I would see that 60 would be the smallest number, and then we would have 63 would be the next smallest number. So we'd have 63. And then we would have, after 63, we would have 65. And I'm just crossing them off as I write them so I could keep track. And then we have 68, and then 69. Cross this off, and then we have 73 would be the next smallest number. And then we have 2 76s repeating. Okay, so 76, 76. So if we're looking for the median for Team A, there are 8 different player heights written here. So we have 1, 2, 3, 4, 5, 6, 7, 8. So the median would be halfway between these two here. Okay, so the median for Team A would be halfway between 68 and 69. So that would be 68.5. And now if I were to do this for Team B, I'm just going to write the numbers in order from least to greatest. So we have 62 is the smallest number in the list. Then we have 63. We have 64. And then after 64, let's see, it looks like 67 is the next smallest number. And then 70 shows up twice. So we have 70, 70. And then we have 73 and 75. Okay, and same idea. The median value is going to be here. So for this one, if I'm doing the average of 67 and 70, that would be one way to get the median right away. Or you could just think 67 and 70 are 3 units away from each other. So what we could do is we could just say, all right, 3 divided by 2 is 1.5, and 67 plus 1.5 is 68.5. Okay, but otherwise, if you want to get a guaranteed way to get the median, we could just once again say, for this one, 67 plus 70, and then divide by 2. But that's also going to give us 68.5. But notice here, they're saying for choices C and D that the median height of the players on Team B is greater. And for choice D, we have the median height of the players on Team A is greater. So these two medians are equal. So this tells us we're going to have to calculate the mean of the heights of the players on Team A and Team B. So we want to calculate the mean, so we could just add all of these numbers at once. So I'm going to do 60, and then we have plus 63. And for a scientific calculator, you could write a pretty long sum in there like this, or you could just do one at a time. You could just add pairs of numbers and then just keep adding until you get to the end of the list. So we have plus 69, we have plus 73, we have plus 76, and then 76 again. And now we divide this number by 8, because when you're finding the mean, you want to add up all of the numbers in the data set and then divide by the number of numbers in the data set. So we have 68.75 for that first average. And now for team B, what we're going to do is we're going to type in the sum of those values. So we have 62 plus 63 plus 64, and then we have 67. We have 70 showing up twice, so I'll just add it twice like this. And then we have 73, 75. Okay, so we're adding those. And then I press enter to get the sum and divide by 8. And this gives us all the information that we need. So now we'll just record these values. The mean for team A we have written here is 68.75. Okay, so 68.75 is our first mean. And then if we find the mean of the heights of the players from team B, we had 68. So just looking at this, we could see that the mean for team A is greater than the mean for team B. So now we just look here. So we have the mean height of the players on team B is greater. That's not it. So choice B has to be correct, but let's read this just to be 100% sure. The mean height of the players on team A is greater than the mean height of the players on team B. Choice B is definitely our answer. Question 36, we want to know what is the value of the expression below. And for this one, we want to use order of operations. So I'm going to write out PEMDAS. And a nice way to remember this is please excuse my dear Aunt Sally. But what this tells us is to do parentheses exponents first, then to do multiplication division, and then addition and subtraction. So looking at this expression here, I see that we have division, we have multiplication, we have addition, and we have a negative number here. But what's jumping out at me right away is that we're going to be doing multiplication and division. Now, one thing to point out is that these two operations here are the same rank. So when we see multiplication and division showing up, that means we could just do the operations from left to right. Okay, these are the same rank. So looking at this, even though division shows up after multiplication, I could see here that we're going to divide these two numbers and we're going to multiply these two numbers. Now, once again, I could choose to do 3 times -7 first, but I have multiplication and division are the highest ranking operations here. So they are the same rank. We could just go from left to right. So here I'm going to do -36 divided by 9, and I have a negative divided by a positive is negative. So I'm going to get -4 to start. And then I have plus, because I'm not going to add yet, I'm going to add after I do the multiplication. 3 times -7 is -21, okay, because we're doing a positive times a negative. And then we have plus 2. And now here we have -4 plus -21, and that's going to give us -25. Okay, so we have -25 plus 2. Just know that when you're adding two negative numbers, I'm just pretending that I'm doing 4 plus 21 in my head, or I'm doing 21 plus 4, and that's equal to 25. So if I do -4 plus -21 or -4 plus -21, I'm also going to get -25. So now for the last part here, -25 plus 2, I just think of 25 minus 2 is equal to 23. So if I flip these and say 2 minus 25, this would give me -23. Okay, or I could say this is the same thing as saying -25 plus 2. Okay, so either way, we're going to get -23 here, and choice A is our answer. But remember, you do get a scientific calculator at the test, so you could just type in -36 and then divide by 9, and then write plus 3 times -7. I could put in parentheses like this, and then write plus 2. And notice this is also going to give us -23, so choice A is definitely correct. Question 37, we have a cook uses 1 3/4 teaspoons of salt to make 3.5 pounds of pasta. And we want to know what is the unit rate in teaspoons per pound at which the cook uses salt to make pasta. So if our goal is to find the unit rate in teaspoons per pound, I'm going to set up the ratio 1 3/4 teaspoons, and we'll abbreviate teaspoons with TSP, over 3.5 pounds. Okay, so 3.5, and we'll just write pound here so that the units match. We have teaspoons per pound. So now to find the unit rate, I need to divide 1 3/4 by 3.5. So for this one, what I would do is turn this mixed number and this mixed number into improper fractions and then divide. So here I would do 4 times 1 is 4 plus 3 is going to give us 7. So I'm going to do 7 over 4 divided by, and now I convert 3.5 into an improper fraction. I have 3 times 2 is 6 plus 1 is 7 and then over 2. And when you divide fractions, just use keep, change, flip. You keep the expression on top, so we keep 7 over 4. We change the operation to multiplication. That fraction bar means division. And then we flip the fraction on bottom, which is going to flip to 2 over 7. And now 7 over 7 cancels. Those are matching factors. And we have 2 over 4 left. And 2 over 4 we could reduce by dividing the top and bottom by 2. And this simplifies to 1/2. So the unit rate we could say is 1/2. And then we have teaspoon per pound. Okay, so that means for every pound of pasta, the cook is going to use 1/2 teaspoon of salt. So now we just scan the answer choices here and we can see this is going to match up with choice A. But if you would rather do this math in the calculator, just do parentheses 1 plus 3/4. So 1 plus 3/4. Remember, when you want to write a mixed number in a scientific calculator, instead of saying 1 and 3/4, you would write 1 plus 3/4. And then we're going to divide this by, I put another set of parentheses here, and I have 3.5 is 3 plus 1/2 like this. Okay, and then now I press enter and notice that I get 0.5, which is equal to 1/2. Now, one thing to point out here, the parentheses are very, very, very important. If you just go 1 plus 3/4 and then you divide by 3 plus 1/2 like this, and you don't write any parentheses, notice that you're going to get a number that's different here. And you see 1.75 is waiting for you. Okay, so 1 3/4 is equal to 1.75. They're counting on people not knowing how to use the calculator properly and leaving out the parentheses. Okay, so you just want to make sure that you're doing this, or you could just do it by hand and you're going to get choice A. Question 38, the expression 48y minus 16 represents the perimeter in feet of a square. And we want to know which expression represents the length in feet of each side of the square. So for any square, just know that all of the sides are equal in measure and all of the angles on the inside are right angles. They are all 90 degrees. So if I call the side lengths, let's say S, the perimeter of a square would be 4 times the side length S. I could add these all up. I could do S plus S plus S plus S and get 4S, or I could just multiply it by 4. So here, if they're telling us in the question that the perimeter could be expressed with 48y minus 16, that tells us that 4 times whatever the side length is equal to 48y minus 16. So to solve for the side length, or to come up with the expression for the side length, we're going to divide both sides of this equation by 4. And now, once we get here, there's a nice little technique you need to know for fractions. When you have a fraction like this where there's subtraction going on up top or addition, you could break the fraction up into multiple fractions by the denominator. Okay, so I could write my fraction like this. I just split it up. Now, the concept behind why you're allowed to do that is just think about, let's say I had something like 3 over 7 minus 1 over 7. Okay, in a situation like this, you might just call out the answer right away and say 2 over 7. You just subtract the numerators and you keep the denominator. But the in-between step is combining these two into a single fraction, doing 3 minus 1 in the numerator, and that brings us here. So basically what we're doing at this step is we're going from the middle backwards like this. Okay, so it's like we're making this less simplified in a way, but it's actually going to make our answer match one of the answer choices. So this is helping us simplify. So now we just do the division. The side length is equal to 48 divided by 4 is equal to 12. So I have 12y minus 16 divided by 4 is 4. And that gives us 12y minus 4, which matches choice A. Now, one thing to be very, very careful of here, just know that splitting a fraction up does not work when you have something like this, okay? So I'm telling you not to do this, okay? So don't use this idea in a situation like this. Like, let's say I had 1 over 2 plus 3, okay? We know 1 over 2 plus 3 is equal to 1/5. I just do 2 plus 3. But this, I cannot say that 1 over 2 plus 1 over 3 is equal to 1/5, okay? This is not correct, okay? So you cannot split a fraction up by its denominator. You could only split a fraction up by its numerator, and that's once again when the numerator, the terms are connected by addition or subtraction. But either way here, we're getting choice A. Question 39, we have the equation y equals 4.3x can be used to determine the total cost y in dollars of X pounds of apples. And we want to know, what does the number 4.3 represent in the equation? So for a situation like this, what you could do is you could just start recording some values to make sense of what's going on in the question. So if I make a table of values for X and Y, and let's say I start with X equals 1. So if X is equal to 1, I do 4.3 times 1. So I'm doing 4.3 times 1 is just equal to 4.3. Okay, so I'm just plugging in X equals 1 to the equation to get the corresponding Y value. If I plug in X equals 2, I get 4.3 times 2, and that would give us, we would have 8.6. Okay, and I'll do one more. If I plug in X equals 3, that's going to give us 4.3 times 3. And if I just add 4.3 here, that's going to give us 12.9. Okay, so these are some values that we could look at, and this will help us analyze what's going on in the question. So what we want to answer here is, what does the number 4.3 represent in the equation? So notice 4.3 shows up here. That's our Y value when X is equal to 1. So this is telling us the cost of 1 pound of apples, because they told us here, if we reread this again, the total cost Y in dollars of X pounds of apples. Okay, so this is, the units are in pounds for the X, and Y, the units are in dollars. So really what's going on here is that 1 pound of apples cost $4.30. So if I write this in money form here, we have $4.30. If I write this second value here, we have $8.60, and that would be for 2 pounds of apples. So if you think about it, if 1 pound of apples is $4.30, 2 pounds of apples, I just add this value to itself and I get $8.60. And if I do this one more time, the cost of 3 pounds of apples would be $12.90. Okay, so that's why it's choice C. The cost of X pounds of apples is no good, because that would tell us it would cost $4.30 to buy any amount of apples we want. So I say, okay, give me 5,000 pounds of apples, and I'm only going to pay you $4.30. Like, that really wouldn't make sense. That's why this one is out. And then A and B are no good, because this equation cannot be used to determine the number of apples. They told us right in the beginning that the equation can be used to determine the total cost. Okay, so that's why we're not going to get the number of apples out of this. Choice C is definitely our answer. Question 40, which expression is equivalent to the expression shown below? And for this question, I'm going to use the distributive property first. So we're going to distribute this 3 here, and that's going to give us, we're going to have 2 plus, and then we have 3 times 2x is 6x. So I'm just multiplying 3 times 2, and then the x just tags along. And then we're going to have plus 3 times 5 is 15. And now from this step here, I would combine like terms. So we have these two constant terms here without x's. And this would give us, if we combine here, we're going to have 2 plus 15 is 17. And then we have plus 6x. Okay, so 17 plus 6x matches up with choice C. 41, a teacher surveys a random group of students about their preference for doing classwork online or on paper. And the results are shown in this table here. Based on the results, how many students out of 350 will most likely have a preference to do their classwork online? So for this question here, we're going to use the sample size given here. And we want to know how many students out of the 350 will most likely have a preference to do their classwork online. So we're going to take the online portion here, the 17, and look at that out of the total sample here. So the total sample, I would do 17 plus 8, and we're going to have 17 over 25. So the fastest way to get to the answer is just to take the 350 and multiply it by 17 over 25. Okay, so we could just work this out. So now let's work out this product. We have 350 and we're multiplying by 17 over 25. So 17 divided by 25. And remember, in math, parentheses means multiply. So the product of these two numbers is 238. So the product here works out to 238, so our final answer is 238 students. Question 42, we have Marcy is buying prizes to give away at a fundraiser as described below. So we know that Marcy has $250 to spend, and she's going to buy 13 movie passes that are $9.50 each, so that's 9.50. So we multiply, and this is how much money that Marcy is spending on movie passes. And then she's going to get 3 gift cards for $25 each. So we're going to do 3 times 25 next. And that gives us 75. And the money that she has left, she's going to buy candy bars that cost $1.75 each. So if she has 250 in total to spend, let's do 250 minus this value here. We have 123.5, and this is representing $123.50. And we're going to get this value here. And now we could subtract 75. Okay, so we subtract both of these values here. And this tells us that Marcy has $51.50 left. So that's the rest of the money. And she's going to buy candy bars that cost $1.75 each. So now we could just divide this value by 1.75. And this will tell us the greatest number of candy bars that Marcy could buy with the rest of the money. And she can't buy part of a candy bar, so she could only buy 29 whole candy bars. Now for this question, we can't just write the final answer at the end. We actually have to show our work. So I would just show all of these steps here. I would say that we're going to do 950 or 9.50 times 13. Okay, and this tells us the cost of the movie passes was $123.50. Okay, so $123.50. If you want to throw in the units here for the money, you can. But at the end, we just have to write our correct answer. We could show the work without the units. And then we have the 3 gift cards that are $25 each. So if we do $25 times 3, that's equal to, we have $75. All right, and then from here in the calculator, we did 250 minus 123.50. Okay, so we took the total. So we took the 250 and we subtracted the price of the movie tickets. So that's minus 123.50. And you do get a scientific calculator, so it is okay for you to skip that work. You don't have to show the subtraction that you're doing here. I'm just going to clean this up a little bit. So we don't actually have to show the long subtraction. We can just use the calculator for this part. And we're going to say that this works out to, we have 126.50. All right. And then next, we're going to do minus 75. So minus $75. And that's the cost for the gift cards. And when we did that subtraction, we wound up with $51.50. And then finally, we're doing 51.50. And we are dividing by the cost of the candy bars are $1.75 each. So for this part, I could just get rid of the units because when I divide dollars by dollars, the dollars are going to cancel out. So we divide by 1.75, and this works out to 29.42857, and we have 143. Okay, but here we want to know the greatest number of candy bars. So that's why for our final answer, we are just going to round down to 29 whole candy bars. Okay, so we're rounding this down, and our final answer is 29. Question 43, at a company, a copy machine prints 175 pages in 5 minutes. If the number of pages printed is proportional to the time in minutes, what is the unit rate? So for this question here, we're going to set up, we have 175 pages are printed in 5 minutes. Okay, so to find the unit rate, what we're going to do is we're going to divide 175 by 5. Okay, so 175 divided by 5, we could use a calculator, or I'll just do the long division over here. 5 goes into 17 3 times, and 3 times 5 is 15. We have a remainder of 2. We bring down that 5, and 5 goes into 25 5 times, and it goes in evenly. We have no remainder. So this will simplify. 175 divided by 5 is 35, and the units here are pages per minute. Okay, so we're just dividing these numbers here, and the unit here, the units for this particular rate is pages per minute. So now we just go down to this answer spot here, and we'll just write in that the unit rate is 35 pages per minute. Question 44, a cook removes a package of food from a freezer and begins to defrost the package. The initial temperature of the package of food is negative 15 degrees Fahrenheit. At noon, the temperature of the package of food has increased to 35 degrees Fahrenheit, and we want to know what is the total change in temperature in degrees Fahrenheit for the package of food. So if we want to find the total change, we're going to take the new temperature and we're going to subtract the initial temperature of negative 15. And when we subtract negatives, the operation changes to addition, and we're going to get 35 plus 15. And then 35 plus 15 is equal to 50. So the total change in temperature in degrees Fahrenheit would be 50 degrees Fahrenheit. Now, the concept behind this, let's just say that didn't make a whole lot of sense. What I like to think about is a thermometer. So we have negative 15 is down here, and 0 we'll say is about here, and then we have 35 is, let's say, somewhere up here. So the change that has to happen is we're starting here. We have to get to 0 first. So we're going to go plus 15, and then we're going to go from 0 to 35 is plus 35. So that's why we're doing 35 plus 15 to get 50. But either way, we just have to show the work. We don't have to explain the concept here. We just have to show the work, and the total change in temperature was 50 degrees Fahrenheit. Question 45, we have the members of a school club are selling tickets for a fundraiser, and the goal for the fundraiser is to earn $50 each day from ticket sales. The list below shows the percent of the goal reached each day. So the club is trying to raise $50 each day from ticket sales, and on the first day, the club members earned 90% of their goal. So what we're going to do here is we're going to take 50 and we're going to find 90% of 50. So we could just multiply by 90 out of 100, okay, or 90 over 100. If you know to just multiply by 0.90, then excellent. You could just do, once again, 50 times 0.90, and you're going to get the same thing. So either way, whichever one you're happier with, that's the way you would do it. So the first day, the members of the school club earned $45. On the second day, the members earned 6% more than their daily goal. So that means they have $50, okay, they made $50 or they raised $50, and then they earned 6% more than that, okay? So 6% is 6 out of 100. So they earned 6% over 50, okay? So we're going to do 6% of 50 and then add that to 50, and we get this value here. Now, one thing to be mindful of, what you could do is you could do 50 times 1 plus 6%, and 6%, 6 out of 100, is 0.06. So I could always just multiply by this, and I get 53 right away. And now on the third day, the members earn 14% less than their daily goal. So they wanted to make $50, but they were off by 14%. So that's minus 14% of 50. We're going to do 14 divided by 100. That's 14%. And then we multiply that by 50. And once again, this is going to give us the value here for 14% less than the daily goal of 50. And this tells us how much they earned on that third day. So we could just organize our work over here. So the first day, we have the club members earned $45. And the work that we have to show is we're going to take $50 and we're going to find 90%. Okay, so we're going to multiply by 0.90. So I'm just going to write 0.90. And once again, you are allowed a scientific calculator, so you don't actually have to show the long multiplication. You could just show that you're getting 45 here. And now for the second day, so the work for the second day, the members earned 6% more than their daily goal. So we could just show this second way over here. We could do 50 times, and we're multiplying by 1.06. If you want to show the long way, you find 6% of 50 and then add that to 50, you can. But you can just do it in one shot like this. This was, once again, the short way to do it. But either way, however you show the work, as long as the work is valid, is fine. Okay, and we'll just make that a little bit neater. So this is our work for the second day, and this worked out to 53. And now for the third day, we had that the members earned 14% less than their daily goal. Okay, so that work we could just show we have 50 minus 14% of 50. So we're multiplying 14 out of 100 by 50. Okay, so we're multiplying 14 over 100 by 50. And when we do the work in the calculator, this should work out to 43. Okay, so this works out to 43. So the actual question here is how much money in dollars did the members earn from ticket sales on all 3 days? So now what we're gonna do here is we're gonna add these three numbers up. Okay, so the total earnings here, we're just gonna add up. We have 45, and then we have 53, and we have 43. Okay, so we're adding these up. We could use a calculator for this, but this addition isn't too bad. We have 0 plus 0 plus 0, and we're doing that twice. And then we have 5 plus 3 is 8. 8 plus 3 is 11. We carry the 1. So now we have 5 plus 5 is 10, plus 4 is 14. So the total earnings for the 3 days is $141. So that would be our solution to question 45. Question 46, a student incorrectly simplifies an expression, and the expression and the student's work are shown below. And then we have, in which step did the student first make an error? And then we want to include the correct value of the expression in simplest form in our answer. And we have to explain our answer. So if we look here, 5 minus 40 divided by 5, notice right away in step A, the student made a mistake. They distributed the minus to the top and bottom to the numerator and denominator of this fraction. They would have to do something like this. They would have to say 5 minus 40 over 5 is equal to, and this we could say is equal to 5 plus, and I could send the minus to the top or the bottom. I can't send it to both. Okay, so I could say this would be fine. I could say 5 plus negative 40 divided by 5. This is okay. And then this would simplify to 5 plus, and we have a negative divided by a positive is a negative, and we have 40 divided by 5 is 8. So this gives us 5 plus negative 8. And then if I do 5 plus negative 8, I just think of 5 minus 8 is negative 3. This would be the correct answer simplified here, not 13. Okay, so here we just have to explain the mistake. This student distributed the negative to the top and bottom here. They should have wrote 5 plus negative 40 over 5 instead. Question 47, Miss Boy spent a total of $175 for 4 admission tickets and for parking at a baseball game. The cost of each admission ticket was the same amount, and that's including tax. And the cost of parking was $25. And first we have to write an equation that could be used to determine T, the cost in dollars of each admission ticket. And once again, the tax is included. So for this question, what I would look at is the type of value we're dealing with in this equation. So 25 represents the cost of parking, and this is a fixed amount. You just pay the parking fee once, so that's just 25 plus. But what will change is how much money you spend on tickets. And there are 4 admission tickets being bought, and they are T dollars each. Okay, so we're going to say 25 plus 4 times T, where T is the price of a ticket. And we know that the total bill here is 175. So once again, the reason why the 4 is going in front of T is that we know that Miss Boy bought 4 admission tickets and they cost T dollars each. Okay, so that's why we're multiplying 4 and T, and we're not doing 25 times T. The parking fee is constant, so we just leave this alone. And now the question here is, what was the cost in dollars of each admission ticket, including tax? And we have to show our work. So from here, what we could do is we could just solve this equation. So we have 25 plus 4t is equal to 175. And we could solve for t by subtracting 25 on both sides first. Okay, so we're going to do minus 25 on both sides. And we have 25 minus 25 canceling. And then we have 4t is left on the left side. And if we subtract here, we're going to have 150. Okay, we're doing 175 minus 25. And from here, we just divide both sides by 4. And this we could just type into a calculator. If we do 150 divided by 4, we're going to get 37.50. If you want to do this mental math, you could just divide 150 by 2 twice. So what I do is I do 150 divided by 2 is 75. And then from here, I do 75 divided by 2 is 3750. Okay, so this is just a little mental math exercise, but you do get a scientific calculator for this test. So you can just type this in the calculator. And now we just record our answer at the end. The price of one ticket is $37. And let's just make sure this is neat. So we have $37.50. Question 48, our final question. We have a company manufactures water bottles. The list below describes the number of water bottles manufactured in 3 months. And we're starting off here knowing that in February, 4,100 water bottles were manufactured. In March, 7% more water bottles were made than in February. So from here, what I would do is I would take 4,100 and I would find 7% of 4,100. But then we could add it back onto the 4,100. Okay, so we could do 4,100 and then we're going to find 7%. So that's times 0.07. And I could find 7% just by converting this to 7 out of 100 and expressing this as 7/100ths. Or if I had to, I could do 7 divided by 100 and see how this is going to give us 0.07. Just be careful not to say something like 0.7. that would be equal to 70%, not 7%. So here I use that value. I'm going to do 4,100 and multiply by 0.07. And we get this value here. And then we could add 287 to 4,100. Okay, so if I just start writing plus, it's going to take my answer that was saved before and add it on. Or I could just do this manually. I could do 4,100 plus 287, and I get this value here. But remember, what I could also do is I could take 4,100 and I could multiply by 1 plus 7%. So I could do 1 plus 0.07, or I could even just write 7 divided by 100. And this is going to take the 7% and add it on for us. Okay, so there's multiple ways that we could get the number of bottles manufactured in March, but this is one of them. And now for April, there were 500 more water bottles in April than there were in March. So this is the amount in March. So I could just take 4,387 and I could add 500 to it to get the number of bottles in April. And that's going to give us this value here. So now we could show the work. So for February, the company manufactured 4,100 water bottles. And then in March, there was a 7% increase. So what we could do is just record what we had in the calculator. We did 4,100, and then we did plus 7% is 7 out of 100, and then multiplied by 4,100. Okay, so this would be the long way to show it. You could just do 4,100 times 1 plus 7%, or I could say 4,100 times 1.07 if I do 1 plus 7 over 100. But showing the work this way is also okay. And this worked out to 4,387. And then for April, what we had was there were 500 more water bottles than there were in March. So now we just take 4,387 and do plus 500. So we have to show the work that we typed in the calculator. We can't just start writing down random numbers here and hope that the people scoring the test are just going to connect the dots for us. We really have to spell everything out. Okay, so we're just showing this sum here in our workspace, and this equals 4,887. And the actual question here is to find what is the percent increase to the nearest percent in the number of water bottles the company manufactured from February to April. So if you just want a formula that you could use, you could just use this formula that I'm about to write over here. So you could do the new value. Okay, so the new value, or the new amount, minus the original amount divided by the original amount. But what this is going to do is it's going to write your answer in decimal form. If you want to express it as a percent, then you just do times 100 like this. Okay, so this we could just type everything into the calculator. So we're doing the new value here, the 4,887, and we're subtracting the original value, 4,100. And this tells us that there were 787 more bottles manufactured in April than there were in February. And now what we have to do is divide by the original amount. So we're going to do 787, that's the difference, divided by the original 4,100. And we get this decimal here. But now to convert this to a percent, we're going to do times 100. And we're rounding to the nearest percent. So notice after the decimal is a 1, so we would round down to 19%. So let's just show this work now. So we're doing the new value, 4,887, minus the original value, 4,100, and we're dividing by the original value, 4,100. And this gives us the decimal we have here, 0.19. We have 195121. I'll just stop writing here since we could just round down, because ultimately we're going to be rounding to the nearest percent. So this is more than enough. And to show the actual progression to turning this decimal to a percent, we could just take this decimal here and we could multiply it by 100. Okay, so this just shows how to write this decimal as a percent. So I'll say times 100 and then percent. And this is going to work out to, we're going to have 19.195%, but we are rounding to the nearest percent. So we're going to round down to 19%. So our final answer here is going to be 19%.